NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
And then there's the universe, the death of the sun, the collision of the Milky Way galaxy with the Andromeda galaxy, and possibly the Big Rip.
Voyager 1, the spacecraft that's traveled farther than any other from NASA, is still on its incredible voyage through space. It's faithfully sending back priceless data from the farthest reaches of the universe. For almost 50 years, this amazing probe has completely changed how we see outer space. But lately, it's been sending back some unsettling data which has stunned the entire space community. Could these unsettling data be the result of a technical glitch, or perhaps the handiwork of extraterrestrial beings? Come along as we delve into the truth behind these surprising transmissions. Since ancient times, scientists have been fascinated by the enigmas lurking beyond our cosmic boundaries. This insatiable curiosity spurred the historic launch of spacecraft like Voyager 1 and Voyager 2, among other incredible missions. These pioneering endeavors, which have been the subject of discussion for generations, commenced with the liftoff of Voyager 2 from the renowned NASA Kennedy Space Center on August 21, 1977. Just 2 weeks later, on September 5th of that same year, Voyager 1 followed suit. These paired probes, each weighing a hefty 720 kilograms, about the same as a small car, were launched into space during a special alignment of the outer planets. Throughout their remarkable journey, these brave adventurers charted diverse courses and speeds, leading to a significant moment on December 15, 1977. Voyager 1 surged ahead of its twin sibling due to differences in their trajectories. Since then, Voyager 1 has been an invaluable asset, enriching our understanding with a wealth of knowledge and unraveling the mysteries of space. Before delving into the startling new revelation that has sent shockwaves through the space industry, let's take a moment to marvel at the remarkable images captured by these spacecraft. During its groundbreaking mission to image Jupiter in 1978, Voyager 1 was positioned approximately 265 million kilometers away from Earth. From this unique viewpoint, it beamed back an astounding array of photographs. In January 1979, it embarked on an extraordinary 100-hour project capturing a captivating time-lapse video showing 10 rotations of Jupiter. A collection of 3,750 images allowed us to witness Jupiter's majestic movements in exquisite detail. In the following months, Voyager 1 explored the moons of Jupiter, where it made a remarkable discovery: the presence of a faint ring encircling the planet. Furthermore, it brought 2 new moons, Thebe and Metis, to our attention, further enriching our understanding of Jupiter's captivating domain. To ensure a safe journey and avoid any potential collision with Titan, one of Saturn's moons, corrective maneuvers were carried out. Voyager 1 continued its cosmic expedition around Saturn, discovering 4 more moons: Mimas, Enceladus, Tethys, Dione, and Rhea. After completing the Saturn mission, scientists decided to wrap up the Voyager planetary mission, propelling both Voyager 1 and Voyager 2 beyond the borders of our solar system, hurtling through space at an astonishing speed of 325 million miles per year. In January 1990, a new chapter began: the Voyager interstellar mission. It was during this phase that Voyager 1 captured some of the most iconic photographs in history, immortalizing the Sun and the majority of the planets. One key figure who significantly influenced the extension of these missions beyond their original scope was the renowned astronomer Carl Sagan. As a member of the Voyager mission's imaging team, Sagan passionately advocated for the idea of capturing a final series of images, a parting gift to humanity. Despite facing numerous challenges, his steadfast resolve paid off. On February 14, 1990, Voyager 1, situated 6 billion kilometers from the Sun, embarked on a photographic expedition, resulting in what is now famously known as the Solar System Family Photo. These awe-inspiring images, totaling 60 in number, added to the spacecraft's already impressive collection of 670 photographs. During its encounter with Neptune, Voyager 2 achieved a remarkable milestone by recording wind speeds exceeding 1,000 miles per hour, marking it as the fastest wind ever recorded within our solar system. As the spacecraft approached within 2,980 miles of Neptune's vibrant methane-rich atmosphere, it provided us with unprecedented insights into this distant celestial body. Particularly, Neptune's largest moon, Triton, emerged as one of the coldest places within our solar system, with surface temperatures plunging to a bone-chilling -391 degrees Fahrenheit. Triton's peculiar characteristics, such as its nitrogen gas-spewing ice volcanoes that propelled icy particles 5 miles into its thin atmosphere, continued to fascinate our imaginations. These remarkable discoveries expanded our knowledge of the vast diversity and complexity of celestial objects residing in the farthest reaches of our solar system. But before we delve into the Voyager 1 spacecraft's recent chilling discovery, let's take a moment to review its achievements over the last 45 years. The Voyager probes have achieved remarkable feats that continue to astonish. Over 4 decades ago, their initial observations of Jupiter and Saturn's moons left scientists amazed and challenged previous assumptions about these distant worlds. These moons, once believed to be inactive and heavily cratered like our own moon, were revealed to be bustling with geological activity. Voyager 2, in particular, reached several significant milestones during its mission. It made history in 1986 as the first spacecraft to fly by Uranus, and just 3 years later, it accomplished another groundbreaking achievement with a flyby of Neptune. To this day, it remains the only spacecraft to have ventured on such a trajectory. As the Voyager spacecraft continued its voyage, NASA implemented various measures to extend its operational lifespan. Over the last 3 years, non-essential components and heaters have been turned off to conserve energy, ensuring that these brave explorers can continue their mission well into the next decade. Their expected end date for the mission is set for 2030. For the scientists and engineers who have been involved in this remarkable journey from the very start, the conclusion of the Voyager missions is both a moment of pride and a touch of sadness. Their steadfast commitment and tireless work have surpassed their initial expectations by far. The wealth of data sent back by the Voyagers has provided invaluable insights, fueled numerous scientific discoveries, and ignited the imagination of countless researchers and space enthusiasts. Voyager 1 and Voyager 2 were not ordinary spacecraft. They were meticulously designed as stable platforms, with a rotation rate more than 15 times slower than the hour hand of a clock. This design decision minimized visual blurring as the spacecraft captured images and data while speeding through the vastness of space. Even before reaching the outer planets, their impressive imaging capabilities began to astonish both scientists and the general public. The spacecraft began beaming back images of Jupiter several months before reaching the gas giant. These initial pictures, revealing the swirling clouds and the iconic Great Red Spot, brought joy to audiences at NASA's Jet Propulsion Laboratory. However, it was the revelation of active volcanoes on Jupiter's moon, Io, that truly captured everyone's attention. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. Signals detected by the spacecraft's instruments, confirmed by vivid images they captured, unveiled towering volcanic plumes and a surface scarred by volcanic material ejections. Among Io's notable volcanoes, Pele erupted with a force 30 times greater than Mount Everest's height, blanketing an area nearly the size of France. Although the spacecraft's cameras were eventually powered down to preserve power and memory before embarking on their journey into interstellar space, it's worth noting that the images they captured did not include Mercury and Mars for various reasons. Aside from the interstellar probes Voyager 1 and Voyager 2, NASA has overseen other notable spacecraft, including Pioneer 10, Pioneer 11 and New Horizons. Voyager 1 encountered Pioneer 10 on February 17, 1998, marking the moment when Pioneer 10 became the farthest travelled spacecraft. Voyager 1 continued its solitary journey for another 14 years before finally entering the interstellar space on August 25, 2012. Despite no other space probes being in close proximity, NASA did not publicly announce this remarkable achievement until 2013. What strategies ensured the success of the Voyager missions? One particularly ingenious technique stood out: gravity assist maneuvers. These maneuvers played a pivotal role in propelling Voyager 1 and Voyager 2 on their daring quest to explore the outer reaches of our solar system. To reach these distant destinations and gather invaluable data, the spacecraft required more than just their own propulsion systems. They needed a boost, and gravity assists provided exactly that. Picture the two intrepid spacecraft, Voyager 1 and Voyager 2, embarking on their grand tour of the solar system. Rather than solely relying on their engines, the spacecraft engaged in an intricate celestial dance with some of the heavyweight planets in our solar system. This elaborate choreography allowed them to harness the immense gravitational pull of these giants to propel themselves forward. In doing so, they conserved precious fuel and gained the velocity needed to visit multiple destinations. Let's explore the fundamentals of gravity assist, also known as gravitational slingshot. The concept behind this maneuver is to transfer some of a planet's momentum to the spacecraft as it passes by. Imagine Voyager 1 approaching Jupiter, a colossal gas giant with a gravitational force to match. With meticulous precision, Voyager 1 swung by Jupiter at just the right angle and speed. Jupiter's gravity pulled at the spacecraft, accelerating it to a higher velocity and providing it with a cosmic boost. Executing a gravity assist maneuver demands extraordinary accuracy. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot could have resulted in a disastrous deviation from its intended trajectory. The level of precision required is truly remarkable. Nevertheless, the ingenious minds orchestrating these missions flawlessly executed multiple gravity assists, propelling the Voyager spacecraft on a mesmerizing journey through the solar system. Voyager 2, for example, utilized gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were crucial in enabling the Grand Tour. The success of the Voyager missions owes a great deal to these gravity assists. Voyager 1 eventually ventured into interstellar space, with Voyager 2 closely following suit, all thanks to the precision of these maneuvers. While the concept behind gravity assists is straightforward, the execution is incredibly intricate. Voyager 2's Grand Tour demanded a level of precision where any missed slingshot could have spelled disaster for the mission. However, the dedicated individuals behind these endeavors were resolute and unwavering in their quest for knowledge. While gravity assists played a pivotal role in navigating the cosmos, another essential component ensured the success of the Voyager missions: the Deep Space Network, DSN. Think of it as the interstellar communication lifeline that kept us connected with our intrepid Voyager probes as they embarked on their voyage into the unknown. Although less glamorous than a spacecraft, the DSN is equally indispensable. The Deep Space Network comprises a network of large radio antennas strategically positioned across the globe, spanning locations in California, Spain, and Australia. These immense dishes, ranging from 26 to an impressive 70 meters in diameter, serve as cosmic megaphones, enabling communication with spacecraft journeying beyond our planet. Now, let's delve into the role of the DSN in the Voyager missions. Equipped with cameras, sensors, and instruments, the Voyager probes acted as our eyes and ears in the vast expanse of space. To interpret the data they transmitted and provide them with new instructions, a robust communication system was indispensable. This is where the DSN came into play. Consider this scenario. Voyager 1, en route to the outer reaches of the solar system, sends a message back to Earth. It's a faint signal traveling at the speed of light. As it traverses the cosmic distances, the signal weakens. By the time it reaches Earth, it's barely detectable. However, the colossal antennas of the DSN are poised to capture that faint signal. They lock onto Voyager's feeble transmission, amplifying it and converting it into data that scientists can analyze. But the DSN isn't just a receiver, it also transmits commands. The Voyager missions are dynamic endeavors, necessitating scientists and engineers to adapt plans, adjust spacecraft trajectories, or fine-tune instruments. These commands are transmitted through the DSN, which beams them into space to reach Voyager. Essentially, it enables a two-way conversation between Earth and the farthest human-made objects in the cosmos. One remarkable characteristic of the DSN is its relentless operation. It operates tirelessly around the clock, 24/7, constantly listening for those distant signals. It's akin to an unwavering eye on the cosmos, ensuring that we maintain connectivity with our spacecraft even when they are billions of miles away. The Voyager missions serve as a testament to the power of collaboration and innovation. While the spacecraft embarked on their extraordinary journeys, the DSN ensured they were never truly isolated. It bridged the gap between our planet and the unknown, enabling us to explore the outer planets and venture into interstellar space. The Deep Space Network isn't merely a collection of antennas, it's our lifeline to the cosmos. It ensures that the narratives of the Voyager missions continue to unfold, even as the spacecraft journey beyond our solar system into the uncharted realm of interstellar space. Was there a malfunction with Voyager 1? Or could extraterrestrial involvement be at play? Throughout its remarkable 45-year odyssey in space, the Voyager 1 spacecraft has maintained its health, dutifully fulfilling its mission. However, recently, experts have noticed some irregularities in its performance that have aroused intrigue and interest. Voyager 1 is currently transmitting peculiar signals back to Earth, giving the impression that it's uncertain about its exact location coordinates. What adds to the mystery is that the initial data from Voyager 1 was expected to be more coherent and understandable, leaving NASA scientists puzzled. Imagine their surprise when they realized they were receiving these odd signals from the depths of space. Upon investigation, scientists found that the culprit behind the distorted data was the Attitude Articulation and Control System, AACS. This onboard equipment is responsible for measuring, reporting, and adjusting the spacecraft's position in space. It possesses an antenna directed towards Earth, allowing it to transmit data back home. It was discovered that the AACS had unexpectedly switched to sending its telemetry data through a faulty onboard computer that had been dormant for years. NASA engineers were able to resolve the issue by directing the AACS to resume sending data through the correct computer. As a result, uncorrupted data from Voyager 1 is once again reaching NASA. However, the lingering question is why the AACS initially switched to the malfunctioning computer. While NASA scientists have proposed a hypothesis suggesting that a faulty command from another onboard computer might have triggered this unusual behavior, they have yet to identify the exact cause. To unravel this mystery, Suzanne Dodd, the project manager for the Voyager interstellar mission, explained that they intend to conduct a comprehensive memory readout of the AACS and meticulously analyze its operations. This thorough examination aims to diagnose the underlying issue that led to the telemetry problem. It's important to note that despite the irregular data transmission, the AACS itself appears to be functioning correctly, and none of the spacecraft's onboard fault protection systems have been activated. Consequently, Voyager 1 has not been forced into safe mode, and its signal remains robust. One potential contributing factor to this anomaly could be the harsh conditions of space. Cosmic radiation and extreme temperature fluctuations present challenges to the operation of a spacecraft like Voyager 1. Cosmic radiation comprises high-energy particles originating from distant stars and celestial bodies. These particles have the ability to permeate spacecraft structures, leading to electrical disruptions, distortions in data signals, memory malfunctions, and data corruption. Moreover, temperatures in the distant reaches of space can plummet to bone-chilling levels, reaching as low as -202 degrees Fahrenheit, 130 degrees C. Additionally, Voyager 1 is susceptible to encounters with micrometeoroids, dust particles, and fragments from asteroids and comets, all of which can significantly impact its operations. As the spacecraft journeyed into interstellar space, its plasma wave instruments consistently detected dust impacts. When a dust particle collides with the craft at high radial velocity, it is instantaneously vaporized and ionized, creating an expanding plasma cloud that generates a voltage pulse in the electric antenna of the plasma wave system. These energetic collisions with interstellar dust grains have the potential to harm Voyager's functionality. While it has not been confirmed, the presence of interstellar dust particles could potentially contribute to the transmission of unusual data. In an effort to comprehend the nature of these unidentified entities, scientists have explored various scientific theories. One hypothesis posits that Voyager the 1st of May have encountered rogue planets or interstellar objects. Rogue planets, also referred to as free-floating planets, are celestial bodies that lack orbit around any star. These planets roam through space, often unnoticed until they enter the observational range of a spacecraft like Voyager 1. Their discovery challenges our current comprehension of planetary formation and dynamics. Some researchers have even floated the intriguing notion that these unidentified objects might be remnants of ancient interstellar probes or spacecraft now adrift in space. This captivating idea has sparked growing interest within the scientific community as it opens up the possibility of extraterrestrial involvement. The hypothesis is founded on the idea that there could exist an advanced alien civilization surpassing our own technological prowess. According to this theory, these extraterrestrial beings possess superior knowledge of space exploration. It's conceivable that Voyager 1 inadvertently traversed into their territory, potentially elucidating why we have never encountered them previously. Perhaps they exist at distances beyond our current detection capabilities. If Voyager 1 indeed stumbled upon their domain, it would be natural for these enigmatic entities to seek interaction with the spacecraft, potentially leading to its anomalous behavior. However, substantiating such an event poses significant challenges, given that our existing technology is limited in its capacity to explore vast distances within interstellar space. The ongoing investigation into Voyager 1's encounter with unidentified objects and the transmission of distorted data continues to captivate both the scientific community and space enthusiasts alike. As researchers delve deeper into this intriguing mystery, they aspire to unveil the true nature of these objects and unravel the underlying causes behind Voyager 1's peculiar experience. The pursuit of knowledge and understanding in the realm of space exploration remains an exciting and ever-evolving endeavor. Thanks for joining us for another episode of Cosmic Discovery. While you're still here, be sure to check out the other videos currently displayed on your screen.